So welcome to the second talk for today, excluding the keynote, of course. So it's the third talk for today. Our speaker is Benoit, who's works as tech lead for Grab1. Is that correct? And he's going to talk about Python and using Elasticsearch in Python. And I'll just hand it over to him.
So, hello everyone. Is it okay? The sound? Yeah. So we've started around a year and a half ago at Grab1 to move from our legacy code base, which was in PHP. Search was using like lots of people percent. We had more and more data in our database. Users are more and more used to search like Google, so they type something, there is spelling correction, it's just giving you what you need, and they're not used to like old way of searching where you have to be exact with your syntax. We started to have performance issues as well on the website because Grab1 is quite popular in New Zealand and was still growing. We had more and more deals. It was slower and slower. So that's basically how our search was looking like before, which is really nice when you look at it, but it's not really working, it's not really scalable. So a year and a half ago, we started to use Elasticsearch, which was just released 1.0 when we started. So what is Elasticsearch? Elasticsearch is a JSON document-oriented data store. You just store JSON with a REST API. It's really simple. You just call the API, you have your JSON, you call another API, and it returns your JSON. It is near real time, meaning that the indexing is not instant. So it's taking a few milliseconds up to half a second to index your document. So you don't want to use this for transactions. You want to use this really for search. By design, it's clustered. You can have multiple nodes. You can spawn them, do replication. It's really, really easy to install. And it's open source, written in Java, and really active. So just basic tutorial how to install it. Just install Java, go on the website, you unzip, and you launch the bin. That's finished. So that's really simple. If you want to test it on your computer, you can do it at lunchtime. You'll see it's really, really easy. So Python ecosystem around Elasticsearch. So the official low-level library written in Python and using the HTTP interface. And more interesting for us, because we're using it, the high-level library, which is a query DSL helper, so helps you to write queries a bit like a Django model query. There is a simple ORM that allows you to save and read and save objects in your database. We use Django, so I wrote a year ago this module for Django debug toolbar, which is exactly the same kind of things than the SQL debug toolbar, but for Elasticsearch. And there is this awesome command line cluster management for Elasticsearch that is written in Python as well and is maintained by Elasticsearch. Practical grid. How do you take something and insert it in Elasticsearch with Python? So that's, what, 8 lines of code, reading a 1 million line CSV, and inserting it in Elasticsearch. There is no more than this, because Elasticsearch use inferred data type by default. If something looks like a date, it will save it as a date. If something looks like a number, it will save it as a number. If something looks like text, it will just do a full text search on it. So it's really easy by default. That's why the learning curve is really in at the start, then comes higher when you try to do more complex things. In Python, how would you do a search for a document? So first, if you want to just get a document by ID, it's just pretty simple. If you want to do a more complex search, you can use this library that will transform this into their query DSL, which is JSON, and you get your documents. So this is basically the JSON that is returned by Elasticsearch for each of your query. So you have a bit of metadata at the top, how long it took, how many shards were used. So a shard is just a place where you store your documents, how many hits you get from your search. In this case, we have 2 of them. What is the max score, which is an important feature of Elasticsearch. By default, everything is scored. So if your text is matching more documents, then the score will be higher in this document. If you have words that are more important for the cluster, the score will be higher as well. And then you'll get your documents, your list of documents, in index, type, the ID, the score, and then the source of your document, which is exactly the JSON document you send it to Elasticsearch. So our first challenge was, how can we connect our MySQL legacy database, our legacy PHP code, into Elasticsearch? So there are many ways to do it. I'm highlighting 4 of them, most simple to most complex ones, and we're using the last one at the moment. So you can have just a CSV you generate every day by your application. You import in Elasticsearch with the 8 lines I showed you. It's working. It's only working, of course, if you don't need real time. But if you're indexing books and you just do them overnight, then there is no issue. You can have a same kind of thing, but with a cron job. Every minute, you read your database. You're like, hey, something's changed. Yes. OK, I'm serializing them and installing Elasticsearch. Then you have just 1 minute. You are just 1 minute behind your main database, which is probably for most people enough. Even for us at Guaban, 1 minute after could be OK. Just sold out will be a bit weird because you'll click on it and it says, it's not sold out. And then 1 minute later, it's sold out. But this is happening all the time on an e-commerce website, so won't really be a problem. Then you can have a database queue using triggers with on-road change, for example. You create a queue, and instantly you read this queue every second, and now you're just 1 second behind your cluster. Or in our case, in PHP, we added a post-save hook. You can do exactly the same thing in Django. And this is posting to RabbitMQ, and then we have a consumer that is reading from RabbitMQ and indexing it in Elasticsearch. So important things, it's Elasticsearch and JSON document store in general are not SQL. So you need to think completely differently. You need to duplicate your data, which is really weird when you come from a SQL word. So if we do these documents, it's just boots and sneakers, but we have a merchant subdocument inside the document, and we are going to repeat his name, repeat his location. This is really important to repeat everything, because then you can do aggregations on name, aggregation on the clustering, but you need each document to contain all info you're going to search on or group by. At the end, you don't have so many fields you need to display to your end user, because you're going to use Elasticsearch for your end users, not for your main data store. You need name, descriptions, some basic info. Just look at your website, look at what's displayed, and you'll see that it's not that many fields at the end. Elasticsearch versus SQL, because everybody's always asking me, so how is it different? How is it working? Simple query, select star from an index with basic pagination. You'll have size from, and you have a limit 2525 in SQL. You have an order by name. You have a comma order by name. It's pretty similar. It's just JSON. But where I found that Elasticsearch is really shining is, by default, even with Django, if you want just to have the number total of results of your search, it's going to do a count star, because there is no way to count your documents without doing a second query in SQL. You cannot retrieve 10 documents and count everything at the same time. So Elasticsearch has these aggregations that are used more and more at the moment with what's called the ELTK stack, which is Elasticsearch, Logstash, and Kibana. It's basically log aggregations and doing aggregations on log, finding graphs and things with maps. It's using the exact same technology. So if you look at GitHub, for example, this page is fairly complex. You have heaps of stuff on the left, you have a total, you have a full text search, you have a list of results with a number of stars, you have pagination at the bottom. This page can be done with one query in Elasticsearch. It's taking, in our use case, around 10 milliseconds to return a page that is that complex. For GitHub, it's a bit longer because they have more documents. And yes, this page is powered by Elasticsearch on GitHub. So if we take a closer look at it, you have two different aggregations at the same time, repository and languages. You have the order by, you have the total of results, and you have the list view as well. At the bottom, you have pagination. So I was somehow inspired by this page and say, hey, we need to do something like this at Grabon, being able to search everything, but just with less I/O than when we have, which was probably around 1,000 SQL queries to display a page. So what type of aggregations can you do in Elasticsearch? Terms aggregation means, for example, if you want to aggregate per category, you'll have the category name, and you'll have the list of categories ordered by the number. Statistics on anything, price bucket, time-based histograms, geo-distance, geo-hash grid. I'm going to highlight a few of them just so you can understand how easy it is in Python to create those aggregations and display them. So if we take the date histogram, the query would be simply ags, which is the keyword for, say, I want to do an aggregation. Then you give it a name. Then you say it's a date histogram. I want my field called date. I want an interval of 1 month. And I want the output format to be with year, month, day. And the result on the right is showing you a list of buckets. And in those buckets, you have the key as a string. You have the key, which is the real timestamp. And then you have how many documents are matching. Then with the Elasticsearch library, in Python, you just have a normal Python object at the end. You can just iterate through it and display it to the user. More interesting, because it's really more difficult to do with SQL Word, is the geodistance aggregation. I want to know all restaurants that are 1 kilometer from me, 5 kilometers, and 100 kilometers from me. It's the same kind of aggregation than the date histogram, but based on locations, and it's out of the box with Elasticsearch. You can easily draw circles, find how many things are near you or far away. And then the one we're using that is even more interesting is the geo-hash, which is doing clustering of points, a bit like Google is doing on Google Maps. When you have multiple points, they group them together, and they say 3 in this area. This is also by default using geo-hash, which is a standard industry for the clustering things on low precision geo. So here's our map with our deals. You can see Christchurch. If there is only one deal matching in the area, it's just going to display it. If we have like 5 of them at the same place, then it will just, for us, draw a circle, say 5 of them. If you click on it, it's going to zoom in because the zoom level will be lower, then it's probably not going to cluster it, and it's going to display them. On the left, I've put our timings at the moment, which are around 17 milliseconds per query. So it's really fast. It's not costly for our servers. Full text search. What do you have out of the box with Elasticsearch and put it on your website? So you have you can search multiple fields at the same time. You can do spelling mistakes. I've put an example with restaurant, and this is just finding words that are more common and closer to this one. You can use synonyms. You can have did you mean autocomplete. And you can also have something that is more like this, which is show me products that are similar to this one, but different. I put the code that is actually doing this more like this on Grabon, and it's 80 lines, which is pretty simple. But what it's doing under the hood is really interesting. It's taking the price point, doing a Gauss reduction around it. It's looking at the text of the document on each document, looking at how many words are common in those documents. And I had like a pizza deal, and I can see 4 other pizzas that are around the same price. The configuration is really pretty minimal to have a result like this. If you tune it, you can have a really powerful more like this search. we started with just search, and then suddenly we realized why are we still using SQL for our website, for our end users? We don't need this anymore. We can display list views, we can display products, we can display everything. So recently we switched to full Elasticsearch for the entire front end. We don't use MySQL anymore for the backend. Only if you're logged in, then the session is a Django session with normal Django, but all pages are just displaying Elasticsearch results. So this data store, in this data store, we also save CMS pages, so like static pages of the website, because at the end it's just another type of document. So the static pages are just a normal document, like any other one. So I talked a bit about the learning curve before. When I started to play with Elasticsearch, I was like amazed at how easy it was. I could do things like the CSV example in 5 lines. And of course, it's becoming more and more harder as you go, because you have to learn a lot about full text search, how it works under the hood, how the IF, IDF ranking is working. You have to dig into it, but it's easy to get started. I found it really interesting. You can prototype something probably for your website in a few hours. I'd love to run one day maybe a sort of hackathon around this with Python and Elasticsearch, and bring your data and we'll try to do something out of it. So in conclusion, I'd say just do it, try it. You'll find a use case probably for your company or for yourself. Keep your prototype really self-contained and try not to put it inside your main application, because we switched from a big monolithic application, and now that we have our front-end IDs separated from the back-end, it's really easy for us to just bring new features without breaking legacy things. It's more than search. Like I said, it's our entire front-end database at the moment. We had nearly no major issue in a year and a half with it. The only one we had was a disk full issue that went badly, but it's a bit our fault. And you still need MySQL, because remember that it's near real time, that you don't have transactions. There is no acidity. It's just pure documents. It's immutable. You need behind the scene your backend with a SQL database, but you can easily push this for your user with Elasticsearch. So I have some interesting links here. I'm sure you have lots of questions because you can already see some use case. I'll be happy also if some others are interested to try to create a Elasticsearch user group at some point in Auckland, not Christchurch. So if you are interested with this, come talk to me later, and we'll see if we can do something.
Thank you, Benoit. So I'm sure this talk will spark a lot of interesting questions, and I'm pretty sure most of you will have some use case for Elasticsearch. So please, any questions?
Do you know if it's at all feasible to use it as a component in a desktop client-side application?
I'd say if your client is in Java, yes, because it's Java-based. You could potentially install it even if you use Python and your clients have Java on their machine. Installing it, there is no install. It's just a binary to run, so a jar to run. So yes, definitely you could potentially ship it with your program, run it behind the scene using Python to run the binary, and it's just running. It's using under the hood Lucene indexes, which is used by Solar as well. And for example, an IDE like PyCharm is using this under the hood to do the search on PyCharm. So but it's fully Java, it's easier for them because they just interface with Java.
Hello. When you were thinking about switching to Elasticsearch, did you consider Postgres as opposed to MySQL, considering Postgres has full text support as well, text search support, as well as PostGIS for doing the GIS style queries?
So I've used PostGIS when I was working at Yellow to do the same kind of things, and I switched to Elasticsearch because first, it's faster. For millions or billions of documents in Postgres, it's just not fast enough because it's not distributed. You can have around, I think GitHub has more than 500 nodes, so 500 servers with Elasticsearch clustered. Then you can really do aggregations on those 500. With Postgres, you'll have an issue with this. The full text search, yeah, it's kind of the same, but then you have more features. It's easier to interface because it's JSON, so it's working everywhere. But I started with Postgres. It's definitely good for starting. Elasticsearch is more powerful.
It was a good talk, thanks. When you were listing out the ways that you were doing the updates, did you say that you'd sort of essentially moved through those and you'd settled on the last one where you're doing using a Django hook?
Yeah. This one? So yeah, we are using the last one in PHP and Python. So we still have part of our backend that is in PHP. So it's a Symfony backend. And there is the same thing that post save hook. So when we save anything, we are serializing it and pushing it to RabbitMQ.
Right.
And then we have our front end, which is just a Django application with a consumer that is listening to the queue, indexing documents all the time as they come in. At the moment, we have two backend systems, one in PHP, one in Python. So we need a way for them to talk to the front end, and RabbitMQ with both of them sending documents is a good, easy way for us.
Right. Okay. Good. Thanks. And the other question was, when you first used it, did you use a book? Did you make use of a book which you would recommend?
No, but not when I started. But I can recommend one now, which is the official Elasticsearch book. I don't remember the name, but it's on their website. It's an ebook and a physical book as well. I'm not sure the physical book is released yet. It's probably in the next few months that is supposed to be released. And I read it. It's a massive one, but it's really good. I was a bit in the dark when I started because it was still 0.9 when I started. 1.0 came, drew a lot of attention at it, so now it's way better to find documentation and being helped, and this book is good.
Hey Benoit. So you said that you started off with MySQL and then you moved to Elasticsearch. You're no longer using MySQL.
Yeah.
Are you still using the source data? So is that MySQL still your source of truth for your data or not?
This is correct. MySQL is our source of truth, but we're not exposing it to our users. It's only our admin people or salespeople that are entering deals on the website that are using a website powered by MySQL, but the front end itself, when you search or look at deals, which is not true for cart. For example, cart and transactions on the websites are still happening with a transactional database. We're not using Elasticsearch for transactional things because there is no transaction, so it's a bit hard to roll back if you have an issue. But the entire front end, you don't need most of the time a SQL database. You can just use JSON document store.
And how do you back up your Elasticsearch indexes? Is there any formal way of doing it?
So that's a very good question. There is an awesome built-in snapshots restore feature where you can just run from REST API, please back up my Elasticsearch to this path, and then you'll have a backup. And then from any other cluster, you can say, please restore from this cluster using REST API. So yeah, it's built in. We are using it. We are also, I've restored on my dev computer, the production cluster, and it's coming back from prod directly. And I have a local cluster that is exactly like prod.
So how would you compare it to something like Solar?
It's really similar because under the hood they're using Lucene, so it's same speed, same kind of features. The difference is Solar is pretty rigid, and that's exactly why the guy that created Elasticsearch called it Elasticsearch, because he found Solar really rigid, and he said, I'm going to call it Elasticsearch because it's less rigid than Solar. I said that it's way easier to get started with Elasticsearch than Solar. You can do really good things with Solar, but you need to know what you're going to do. With Elasticsearch, you can figure out as you go.
We still have time for a couple more questions, even if they're really complicated. I'm pretty sure Benoit is happy to answer them. If there are no questions, please join me in thanking Benoit again.